everybody, I would like to welcome you to our 9th video in the pre-algebra playlist. And in this video, we are going to go over the order of operations. So the order of operations is a very important concept in math that you need to learn because many times, or actually 99% of the times, when you're evaluating expressions involving numbers, they won't just contain a single operator. So it won't just be addition or subtraction or multiplication or division. Most of the times, it will be a combination of two or even all of them in the same expression. So there is a certain method to the madness that needs to be followed. One way that you can help yourself remember this method is through the famous PEMDAS. Now, the PEMDAS mnemonic is something like this. Most teachers in elementary school, middle school, or whenever you learn the order of operations, they tell you that the P stands for please, the E stands for excuse, the M stands for my, the D stands for dear, the A stands for aunt, and then the S stands for Sally. So the PEMDAS mnemonic that is supposed to help you remember the order of operations is somehow supposed to stand for please excuse my dear Aunt Sally. Now personally, I find the please excuse my dear Aunt Sally portion of PEMDAS completely useless and highly annoying because it has nothing to do with the order of operations. Now, in reality, when thinking about mathematical terms, the PEMDAS is supposed to stand for parentheses, exponent, multiplication, division, addition, and subtraction, like this over here. So, what this PEMDAS tells you is that when you're given a numerical expression which contains more than one operation symbol, such as the addition, subtraction, multiplication, division, you are supposed to first evaluate the parentheses, then move on to the exponents, the multiplication, division, addition, and lastly do the subtraction. But that is not the whole story either. The PEMDAS mnemonic is flawed because when one looks at it, one thinks that first I should always evaluate the parentheses, then the exponents, the multiplication, division, addition, and lastly always do the subtraction. But that is not really the case. What happens is that the multiplication and division fall under the same rank. Similarly, addition and subtraction fall under the same rank. So, if you encounter going from left to right in your numerical expression, subtraction before addition, you are supposed to evaluate that before addition. So, my version of PEMDAS can be broken down into 4 ranks. In the first rank, you always evaluate the parentheses no matter where they are in the numerical expression. In the second rank, you always evaluate the exponents before moving on to any other operation symbols. In the third rank, you don't always evaluate multiplication before division. You evaluate multiplication or division, depending on what comes first when you evaluate your numerical expression from left to right. And in the fourth rank, similar to multiplication and division, I evaluate addition or subtraction depending on what comes first when I'm evaluating my numerical expression from left to right. So these ranks over here are pretty much the more accurate version of PEMDAS that you should follow. Now, if you're watching this video from maybe Europe or Asia, PEMDAS is still common over there, but a more common terminology over there is BODMAS. So BODMAS stands for brackets, order, division, multiplication, addition, and subtraction. Now, there's no really fancy way of saying BODMAS like please excuse my dear Aunt Sally. So that's a good thing. But instead of the parentheses, the terminology used is brackets. And instead of using the word exponents, the word used in BODMAS is orders. So orders of numbers and the exponent of the problem are the same exact thing. And then the D, M, A, and the S all stand the exact same way as they do in PEMDAS. So now that you know how to properly perform order of operations from left to right, not using PEMDAS, but using these four ranks over here, let's do a few examples. In this first example, where we perform the order of operations correctly, let's say I have something like this numerical expression right over here. This numerical expression over here is read as the quantity of 2 minus 1 squared. So basically, if you have parentheses around anything, in this case 2 minus 1, that is read as the quantity of and whatever is inside the parentheses. So the first portion over here is read as the quantity of 2 minus 1 squared. Now, moving on, we say times 10 divided by 2 plus 5 minus 3. So, when we start to solve this problem, we know that the first thing that we need to solve, according to the ranks that we went over in the last page, is whatever is inside the parentheses. In this case, we solve 2 minus 1 before moving on to the next portion. So, 2 minus 1 will give me 1. I rewrite the problem over here like this now. Since 1 squared is the same thing as saying 1 times 1, I can simply rewrite 1 squared as 1. So this is my more simplified version of the numerical expression from the last step. Now, according to PEMDAS, I either do multiplication or division, depending on what comes first when I go from left to right. In this case, multiplication comes before division, so I perform 1 times 10 first to give me an answer of 10. Now I rewrite the numerical expression again. Before moving on to addition and subtraction, according to the ranks that we went over in the last page, I need to perform the division operation first. So 10 divided by 2 will give me a 5. Now I rewrite the remaining terms. Now I either do addition or subtraction first, depending on what comes first when I go from left to right. Since addition comes first before subtraction, I perform the operation of 5 plus 5 before I move on to subtraction. So 5 plus 5 gives me 10. And finally, 10 minus 3 will give me an answer of 7. Now let's do another example. In this second example, let's say I have the following numerical expression over here. Now all this seems really complicated, but let's just take it according to the order of operations. The first thing that we need to realize is that instead of 1 parentheses, we have 2 over here. The first one is the 4 plus 8, and the second one is the negative 6 over here. Let's just start off with the first parentheses we encounter. So 4 plus 8 will give me a 12. Now I rewrite the remaining terms of this numerical expression. The next thing that I evaluate is the second parentheses in this problem. The second parentheses is negative 6 squared. That is the same thing as saying negative 6 times negative 6. And we know that when we multiply two negatives together, we get a positive number. So negative 6 times negative 6 will give me a positive 36. Now referring back to the ranks of the order of operation, the first thing that I do is that I evaluate the multiplication or the division. But since multiplication in this case comes before the division operator, I multiply negative 4 and 3 together. Negative 4 times 3 will give me a negative 12. Now I move on to my rank again and see that division is the one that I need to perform before addition and subtraction. So negative 12 divided by 6 will give me a negative 2. Going from left to right, I know that the first thing that I need to do is perform the operation of negative 2 plus 3. That will give me an answer of 1. Now before performing 12 plus 36, the first thing that I need to do is perform 1 minus 12. So 1 minus 12 will give me a negative 11. And then finally I do negative 11 plus 36. That gives me an answer of 25. Let's do one more example. In this third example, let's say I have this following numerical expression over here. Now let's do the solution to this problem. We realize that there are a lot of parentheses and brackets that are involved in this problem. So let's just do it step by step. The first parentheses that we encounter in this problem is the quantity of 8 times 4. We already know that 8 times 4 will give me a 32. Over here, we have something called a parentheses inside a parentheses. Now, you can have as many parentheses you want inside a parentheses, that doesn't really matter. But what we need to do is that we need to work out from the inside out. So the first thing that we do is evaluate the parentheses that is inside the parentheses. So we evaluate 6 minus 3 to give us 3. Now again, we evaluate the inside of the parentheses, but in this case, we do the multiplication part before the addition part. So 4 times 3 will give me a 12. Now, I perform the addition operation inside the parentheses to give me a 16. Finally, I perform the last operation of 32 divided by 16 to give me a final answer of 2. Now let me do one more example before I leave you in this video. But in this example, I will write down the math portion of the numerical expression into words, and then we will convert it into a numerical expression, and then we will evaluate it. So let's say you are given the following sentence over here. 10 more than the product of the numbers 6 and 11. So the first thing that we can do is that we can rewrite this word phrase over here and replace the words with numbers where applicable. So I can rewrite this sentence over here like this over here. Now that we have done this step, the next step is to recognize what operations we need to perform in this sentence. So when we read it, 10 more than implies the addition symbol. When we continue reading this, we hear the words product of the numbers 6 and 11, and we know the product implies multiplication. So there are two operations that we need to perform in this problem. One of them is addition and the other one is multiplication. Referring back to PEMDAS tells us that we need to perform the operation of multiplication before addition. We can find the product of the two numbers before we move on any further. Since the product of the two numbers equals the product of 6 and 11, we can simply multiply 6 and 11 together. And when we multiply 6 and 11 together, that gives us 66. Now, referring back to the first part of the problem, it tells us that our answer is equal to 10 more than the product of the numbers 6 and 11. Since we already know that the product of the numbers 6 and 11 is equal to 66, we can find our answer by simply adding 10 more to it. When we add 10 to 66, we get 76. So our final answer is equal to 76. So in this video, you learned a very important concept of correctly performing the order of operations. I hope you learned a lot from it and you enjoyed it thoroughly. Keep on working hard, and I'll see you in the next video.